Hi friends, once again welcome back in our educational channel, that is SYJC Electronics. Friends, in this video lecture we are going to study the concept of edge trigger flip-flop and the type of edge trigger flip-flops used in sequential logic circuits. So friends, what is edge trigger? So edge trigger flip-flops are used to remove the drawback of clock flip-flop. What is the drawback of clock flip-flop? In clock flip-flop, the transition of state occurs only when the clock input is high. When clock input is in low condition, when we are applying low clock input, the flip-flop is in disable mode and the transition of state does not occur and the flip-flop remains in the last state. So, the flip-flop is in enable mode only when the clock input is high. But friends, there are many applications in which we require the transition of state at the edges, that is a positive edge or negative edge of the clock pulse. And this positive edge, when these edges are applied to the flip-flops, these flip-flops are known as edge trigger flip-flop. First of all, what is clock? The square pulses, when that square pulses applied to the flip-flops, it is known as a clock flip-flop, and that pulses are known as the clock pulses. The actual clock pulse, the figure of clock pulse is now displayed on your screen. And there are edges 1, 2, 3, 4, 5, 6, 7, 8. The edges 1, 3, 5, 7 are known as positive edges because these are the edges at which the voltage of the clock pulse changes from low to high, it is from 0 to 1. So these edges 1, 3, 5, 7 are known as positive going edges, while the edges 2, 4, 6, 8 are known as negative going edges because the voltage or level of that clock pulse changes from high to low, that is from 1 to 0. So these edges are known as negative going edges. And when these edges in the transition of flip-flop occurs at the positive or negative edge of the clock pulse, these flip-flops are known as edge trigger. But this clock pulse is not directly applied to the clock terminal of clock flip-flop. It is converted to the spikes and then that spikes are applied to the flip-flop. And when the spikes are applied, it is known as edge trigger flip-flop. And how these clock pulses are converted to the spikes? For that purpose, a special circuit is used. And in this circuit, the capacitor and resistor are used. And when the capacitor resistor circuit is used to convert the square pulse into the spikes, this circuit is known as differentiator. That means a differentiator circuit is used to convert the square pulses into positive and negative going spikes. The circuit diagram of that differentiator is now going to display on your screen. At the input terminals, at the input sections, the capacitor is used and the resistors deliver the spikes. The clock pulse is applied to the capacitor terminal and the resistor deliver the spikes. And that clock pulse and the spikes are also displayed on your screen. The spikes are there. Okay? How this circuit converts? The inputs are applied to the capacitor and output is delivered by the resistor, and this circuit converts the positive going edges, the positive part of the clock pulse into the positive spikes and negative part of the clock pulse into negative spike. And when this pulse is applied to the flip-flop, it is known as edge trigger flip-flop. That is the concept of edge trigger flip-flop. Means by using the differentiator circuit, we are going to convert the clock pulses into spikes. Now there are two types of edge trigger D flip-flop. We are going to study the edge trigger D flip-flops, and there are two types of edge trigger flip-flop. That is positive going edge trigger flip-flop and negative going edge trigger flip-flop. And we are going to study the positive going edge trigger D flip-flop. Similarly, there are positive going RS flip-flop, positive going JK flip-flop, negative going JK flip-flop, etc. So we are going to study the positive edge trigger D flip-flop. The logic diagram of positive edge trigger D flip-flop is now going to display on a screen. From this diagram, it is clear that the input clock pulse is applied through differentiator circuit. The capacitor and resistor networks is used and then a diode is used, and the output of this network is applied to the clock terminal of D flip-flop. This RC network convert the square pulses into the spikes. The positive going and negative going clock pulses or edge triggers or edge pulses are applied to the diode circuit. RC network convert the clock pulses into the spikes, and these waveforms are now applied to the diode. What is the use of diode? Diode is used to pass only the positive pulse through it, and that applied to clock terminal of D flip-flop. When the negative pulse is applied, the diode is in reverse mode, so that negative pulse will not be able to pass through the diode. It will get blocked. That means only the positive edge is able to pass through diode, and the positive edge is applied to the clock terminal of flip-flop. That's why it is known as positive edge triggered D flip-flop. Now, how this circuit works? The transition of state, that means the flip-flop is in enable mode only when the clock pulse, that is high edge, is applied. That means when the clock pulse is high. At the transition of state, the flip-flop is in enable mode because the positive edge is applied to the flip-flop. So the transition of state occurs as per the data inputs. If the clock pulse is high, suppose clock pulse is low, first clock pulse is low. When low clock is applied to the flip-flop is in disable mode. So whatever may be the data input, the flip-flop remains in a last. The transition of state does not occur. The transition of state occurs only when the clock pulse is high. That means the flip-flop is in enable mode. That means when clock pulse is high, the flip-flop is in enable mode, and as per the data input, the flip-flop is in set mode or reset mode. Suppose data input is high, the flip-flop is in set mode, so outputs are Q is equal to 1, Q complement is 0. When clock pulse is high, data input is low, the flip-flop is in reset mode, and output goes to Q is equal to 0, Q becomes low, while the Q complement is high. That means flip-flop is in reset mode. So in this case, the positive edge is applied to the flip-flop, and as per this positive edge, the flip-flop changes its state. The transition of state occurs. This flip-flop is known as positive edge triggered D flip-flop. The symbol of this positive edge triggered D flip-flop is now going to display on the screen. There is data input D, and the clock pulse is applied. There is a clock input, and this clock input is applied to the flip-flop, and in that flip-flop the triangle is there. In that symbol, triangle is there, and this triangle indicates it is positive edge. It is a edge trigger, and it is a positive edge trigger flip-flop. The truth table of positive edge trigger flip-flop is now going to display on your screen. In that truth table, clock input is there, data input is there. So these are the inputs. Then Q and Q bar or Q complements are the outputs. When clock input is low, the flip-flop is in don't care state. So whatever may be the input, the flip-flop remains in last. So that input is denoted by cross. The cross means don't care. When clock input is high, that is edge trigger, positive edge is applied, and this positive edge indicated by upward arrow. When the positive edge is applied, data input is low. When D is 0, the flip-flop is in reset mode. So Q remains low, or Q goes to low level, and Q complement becomes high. So flip-flop is in reset. When clock input is high, data input is high, the flip-flop is in set mode, hence Q is equal to 1, Q bar is or Q complement is 0. That is positive edge triggered D flip-flop. The next flip-flop, that is negative edge triggered D flip-flop. It is negative edge. So in this case, the negative edge is applied to the flip-flop, and the transition of state occurs at the negative edge. This flip-flop is known as negative edge triggered flip-flop. The logic diagram of negative edge triggered D flip-flop is now going to display on your screen. The same circuits, that is capacitor and resistor, that is a differentiator is used, then diode is used, but between the differentiator circuit and diode, inverter is used, that is NOT gate is used. What is the function of NOT gate? the NOT gate gives exactly opposite of input. The output of NOT gate is exactly opposite of input. That means it is a complement of input. If input is high, output of NOT gate is low. If input is low, output of NOT gate is high. That means we are getting the complemented output of input. That means the positive spikes are converted to negative spikes and negative spikes converted to positive spikes. So output of this NOT gate is complement of input and that output is applied to diode. So diode once again block the negative pulse and able to pass the positive pulse through it. That means the positive spikes are applied to the flip-flop. But friends, this positive spike is basically negative spike and that negative spikes converted to positive spikes by using NOT gate. So this is the negative clock edge. Basically it is negative clock edge which is converted to positive spikes. So the transition of state occurs at the negative edge of the clock pulse. So it is known as negative edge triggered D flip-flop. So in this case, the RC network converts the square pulses into the spikes. Then inverter is used to convert, which gives the inversion of the input applied to that NOT gate. So the positive spikes converted to negative and the negative spikes converted to the positive spikes. And the spikes are applied to diode and diode is able to pass only the positive spikes through it and that is applied to the clock input terminal of D flip. Now transition of state occurs at the negative edge of this clock pulse. And the transition of state will depends upon the data input. When the clock input is high, when the clock, that is the initial input, when the clock input is high, flip-flop is in disable mode and the output will not be changed. It remains in a last state. So transition of state will not occur. So flip-flop remains in last state. Next, when the clock input is low, flip-flop is in enable mode. Why is enable mode? Because this negative edge converted to positive edge and then applied to the clock terminals. So when the clock input is low, the flip-flop is in enable mode and as per the state of the input, that is a D input, the flip-flop is in set mode or reset mode. That means it data input is high. Sorry. If data input is high, clock is low, the flip-flop is in set mode and output of flip-flop now becomes Q is equal to 1, Q complement is low, so flip-flop is in set mode. Next, when the clock input is low, data input is also low, the flip-flop is in reset mode and the output of the flip-flop is now Q is equal to 0 and Q bar, that is Q complement, goes to high level. That means the flip-flop is in reset mode. From this we can conclude that when the clock input is low, in this case the flip-flop is in enable mode and as per the data inputs, the flip-flop is in set mode or in reset mode. Now the symbol of this clock negative edge triggered D flip-flop is going to display on your screen. In this symbol there is one change. What is that change? The clock pulse is applied to the clock terminus and there is a bubble and this bubble indicates it is inverter. There is an inverter. So it is a negative edge triggered and that negative edge is applied to inverter. That's why it is known as negative edge triggered flip-flop. The triangle is there. The triangle indicates it is a edge triggered. Bubble indicates it is a negative edge triggered. So it is symbol of negative edge triggered D flip-flop. Now the truth table of negative edge triggered D flip-flop. There are two inputs, that is a clock input and the data inputs. There are two outputs, that is Q and Q complement. When clock input is high, flip-flop is in don't care mode. The output of flip-flop remains in last state because the flip-flop is in disable mode. So whatever with the data input, the flip-flop remains in last state. That means when clock input is high, flip-flop is in disable mode, output remains in last state. When clock input is low, and this low clock is given by downward arrow. In this case, downward arrow is used. This downward arrow indicates the negative edge. So when the clock input is low, data input is low, the flip-flop remains in reset mode or it is in reset mode. So Q is equal to 0 while Q complement is 1. Next, when clock input is low, data input is high, the flip-flop is in safe mode, so outputs are now Q is equal to 1 and Q complement is 0. So that is negative edge triggered D flip-flop. So friends, thanks for watching this video lecture. In next video lecture, we are going to study the next type of flip-flop, that is JK flip-flop. So once again, thanks for watching this video lecture. Bye. Take care. Keep watching these video lectures. Bye. See you again.